Hello and welcome. My name is Mal G, and I would like to present Divisibility Rationalised. Let's choose 43 from Table 1 and ask what multiple of 4 added to what multiple of 3 will add to 43. Looking at row 5, column 7, you'll see 43 printed in red, and below it are 7 and 5 printed in black. 43 is the divisor, that's what we're dividing by. The 7 I've named operator 1, the 5 I've named operator 2. Split 43 into its two parts. Multiply 4 by operator 1, that's the 7, that gives you 28, and multiply 3 by operator 2, a 5, and multiplying gives you 15. Adding the results, 28 plus 15 is 43. Another example, split 87 into its two parts, 8 and 7. Multiply 8 by operator 1, which is 3. Multiply the 7 by operator 2, which is a 9, and add the two results together. 24 plus 63 gives 87. This brings us on to how to use this table. Is 38 a factor of 114? Well, split 114 into its two parts, 11 and 4. Operator 1 for 38 is 2. Operator 2 for 38 is 4. And when we multiply out, 11 times 2 is 22, 4 times 4 is 16, which when added together gives 38. So 38 is a factor of 114. As another example, is 67 a factor of 201? Well, if you split 201 into its two parts, you've got 20 and a 1. Operator 1 for 67 is 3. Operator 2 for 67 is 7. Multiply out, and you get the two results, 60 and 7, which added together gives 67. So 67 is a factor of 201. Occasionally, you may come across a divisor that does not do what you expect. 13 is such an example. Is 13 a factor of 78? Split 78 into its two parts, 7 and 8. Operator 1 for 13 is 7. Operator 2 for 13 is 2. If we do the multiplication, we get 7 sevens are 49, 8 twos are 16, and added together gives a result of 65. So is 13 a factor of 65? Split 65 into its two parts. Operator 1 for 13 is 7. Operator 2 for 13 is 2. When we multiply, we get 42 and 10, which gives a result of 52. So is 13 a factor of 52? Well, split 52 into its two parts. Operator 1 for 13 is 7. Operator 2 for 13 is 2. And multiplying out again, we get 35 and 4, giving us the result of 39. Is 13 a factor of 39? Well, split 39 into its two parts, 3 and 9. Operator 1 for 13 is a 7. Operator 2 for 13 is a 2. And once again, multiplying out, we've got 3 sevens is 21, 2 nines are 18, and adding the two results gives you 39. So we are in a loop, and this means that 13 is a factor of 78. The more adventurous will find that a divisor may have more than one set of operators. There is also no column for tens and its multiples, as they do not appear to fit into the scheme of things. But it is not seen as a problem. If you do find a method, please let me know. One or two afterthoughts. A divisor and its two operators always add up to a multiple of 11. If you subtract the column number from 10, it will give you the unit value of the divisor in that column. Across any row, the row number and operator 2 are equal, whilst operator 1 decreases in steps of 1. Conversely, in any column, operator 1 and the column number are the same, whilst operator 2 increases in steps of 1 as you go down a column. A divisor may have more than one set of operators. The final section shows how to determine the divisor and operators for any number excluding multiples of 10. The following three tables consists of divisors 1 through 309 and their associated operators. 23 uses the two operators 7 and 3. Now take 123 and note the two operators 7 and 13. Then go to 223 with its two operators 7 and 23. And we could continue with 423, which uses 7 and 43 as its operators. 523 uses 7 and 53. 623 uses 7 and 63. By now you should see a pattern emerging. The 7 that appears in the above is the same as the column number. The other operator is the row number. And you can expand this approach for other divisors.